Hello everybody. Now I will discuss the second part of this module 8, that is principle and development of additive manufacturing technologies. Actually nowadays in manufacturing sector that it is rapidly moving to the most attractive manufacturing processes, that is called additive manufacturing processes, and of course up to certain extent it is already established, but still some research work is also going on to establish this process for commercial application to produce any kind of the product. But of course it is one of the important manufacturing processes that maybe we should know about this thing and discuss the basic elements of these manufacturing processes with respect to different perspective. So, in additive manufacturing, the definition itself we can see that it is as simple as that manufacturing process that is formed by layer deposition of a particular element. So, this is not limited to only the non-metallic materials. Of course, some metallic materials also used by this technology, and that means additive manufacturing, or sometimes this additive manufacturing process is also called metal printing process also, or maybe simply 3D printing, or very specific to the metallic material. So, of course, this additive manufacturing technology in broadly we can categorize into two parts. One is the metallic, another is the non-metallic components what we can handle. So, a simple layer by layer deposition process, manufacturing process. So, it is not, we cannot create the whole object by following some particular conventional manufacturing process. Rather, we create the 3D objects, and of course, when we create the 3D objects, it is not by following the subtractive methods. Subtractive method means, for example, you want to create this kind of object, round object. So, we can start with this thing, taking a block of metallic material, and we just remove this material from this block and to get the desired step. So, that is simply called the subtractive process, or in general we can say the machining processes. Just remove the material and we get the desired shape. But instead of that, doing in additive manufacturing, what we can do here, first we deposit the one small layer, then next layer, third layer, fourth layer, like that, and that layer by layer we develop, and then to create the final shape of the object. So, that is called the additive manufacturing. So, of course, in the second method, that means in additive manufacturing process, is the effective utilization of the materials normally happens. So, there is no wastage of the, mostly no wastage of the material, because in machining process once we remove the machine by formation of the chip generation. So, that is the, we can say, to get some kind of desired shape, we need to remove the material through machining process. But here, so in that cases the wastage of the material may be high to develop a particular object or particular component, but other additive manufacturing is just opposite. We can minimize the utilization of the raw materials in these cases. So, of course, first we need to create the 3D objects. So, of course, with the help of a computer we can create the 3-dimensional view of this object, and then of course, in these cases computer interface is required. Once we develop the 3-dimensional object, then we create the layer. That basically is simply, if we slice this 3-dimensional object, then it will be created some particular defined thickness, and it's this is called the slicing of an object. And then within this additive manufacturing processes, we just deposit in each and every slice, we just assemble the each and every slice, and we get the object. But what we can achieve these things, and of course, one of the most important aspect in additive manufacturing, once we develop the product by layer deposition. So, surface roughness may be a one general issue for the development of this object. So, maybe we can look into this object. So, we want to create this oval shape object. Of course, the oval shape object can be created by following the machining process, but we need the volume of the material which is more than that of oval shape, and then we use the excess material, and then we can get the desired shape. Now, in additive manufacturing process, the first step is to we make it a more slicing. So, that is called the this is called the slicing. So, it is a small division layer we can create, but this layer created with the computer interface and this created data will be stored in the computer and all this information, and such that when there is a deposition of the material. So, in a particular layer it will be followed by the instruction from the computer which is already from the already stored data. Now, in this case we can say produce this slicing, first we can produce this layer. So, once we develop this layer, then next after deposition of this layer, then we can create the next layer. So, once it is done, then we can go for the next layer. So, that is why we can continuously depositing material, but with the layer by layer formation. Of course, it is restricted what is the length and other geometrical features, it is already restricted to the movement of this source such that it will be the controlled way we can deposit the material up to the thickness, up to the layer thickness. Now, point is that what should be the layer thickness. So, layer thickness can be very small, can be very high depending, but of course, it decides the roughness of this material. So, of course, if we see this is the thickness of the layer and of course, this is the thickness of the layer. So, in these two successive layer, of course, the smooth surface may not be very smooth. So, it creates some roughness actually creates best if you follow the layer by layer deposition, but of course, this roughness smoothness we can bring the smoothness also if it is possible to as minimum as thickness of the layer we can reduce it. Instead of taking very high thickness of the layer deposition, we can follow the very small thickness of the layer deposition. So, when you follow the small layer thickness deposition, probably in this case if we make further slicing, then in that cases we can achieve better surface finish in that case. So, of course, once we produce so many layers in these cases, but of course, the total time to produce a particular object will definitely increase. So, it depends on that. So, therefore, you need to know depending upon the capability of the machine, material deposition capability and rate of the material deposition. Based on that, we can decide the what may be the slice thickness in a particular layer by layer deposition process. Now, in general, the additive manufacturing processes can be classified at the based on this three different mode. So, one is the liquid based. Liquid based means the raw material is in the form of a liquid. Powder based means we can use the material powder to produce a desired shape in additive manufacturing process. In some cases, it can be solid based. Instead of powder, we can use the wire, or we can use the sheet stacking technologies. So, in this case, liquid based additive manufacturing process is as the very oldest process, that is stereolithography, or it can be jetting system also, and direct light processing. These are the three different processes which is based on the liquid based additive manufacturing processes. So, in principle, in the we use some kind of the photopolymer which is sensitive to the laser light, or maybe other kind of, or maybe sensitive to the ultraviolet ray. So, once we want to get the desired product and very precision is required, in that cases we just move the photopolymer according to the desired path. So, along this path, only that part the polymer will be curing and it becomes hard, and then it creates the object according to the desired shapes. But in these cases, we use some kind of the liquid based material. Similarly, for jetting system also, and of course, direct light processing, all this technology depends on this base material in the form of a liquid. Similarly, powder based technologies, additive manufacturing technologies has also been developed, but in these cases we use the raw material in the form of a powder, and once with the form of a powder, then this powder can be sintered or this powder can be fused together with the application of some kind of the external heat source. So, it can be laser heat source, it can be electron beam heat source also, such that if we put the selective position this heat source. So, only that position can be solidified or can be sintered and create the part of the object. So, like that if we follow the similar repetitive way, the layer by layer, the same process, then we can get the whole product using the powder based additive manufacturing technology. There are so many processes has been developed based on powder based material. So, one is the sintering, selective laser sintering, 3-dimensional printing, these are different names, fuse metal deposition system, electron beam melting, selective laser melting, we can see the selective masking sintering, inhibition sintering, electro photographic layer manufacturing, high speed sintering, but all these processes have the different names. There may be different types of the material, different form, different principle it may follow, but in general we can say the powder based system, we use the raw material in the form of a powder, and then that powder is normally either used sintered or fused to get the desired shape. Say third is the solid base. So, instead of using powder, in these cases we can use the wire, and that wire actually continuously feeding of the wire maybe, or maybe we can control the feed rate of the wire, and then wire can be melted and then it deposited, and such that one particular layer can be formed. So, this is the way the solid based additive manufacturing processes has been developed. So, these are the basic classification. Now, we will try to look into the basic manufacturing additive manufacturing processes. We will try to get some overview of all these kind of additive manufacturing technologies. So, in broadly additive manufacturing technologies having the 7 group. One is the binder jetting. So, irrespective of whether it is metallic material or non-metallic material. So, these 7 groups are binder jetting system, direct energy deposition, material extrusion, material jetting, and the powder bed fusion, sheet lamination, and of course, VAT polymerization or we can say the stereolithography. So, in these cases binder jetting means simply in this case binder jetting, or we can use in binder jetting we can use some liquid polymer most of normally, and that liquid polymer is basically cure, or we can mix it hard by application of the some kind of the focused laser or ultraviolet rays also used in the case binder jetting process. Direct energy deposition, in this case we can use the powder directly flowing the powder, and at the same time we can sinter or fuse that powder to make the desired shape. Material extrusion means we can use to pass the metallic wire, or it not metallic wire, it may be some kind of the polymeric material also. Once we pass the wire, and that is continuously we can feed it, and that wire has by application of the heat this wire can be melt, and then it will deposit it in the desired position. So, that is called the material extrusion. Material jetting, jetting means we use the powder or different form of the granular materials can be bind using some kind of binding element. We can bind it, and then we normally use the liquid binder, and such that we can get the desired shape, that is called material jetting. And powder bed fusion means in these cases there is a spread of the metallic or non-metallic powder, but we run the laser in such a way it can melt the selective position, that is called the powder bed fusion. So, once it is done the selective position, we can reuse the unmelted or unused powder also in the next for the formation of the next layer. And sheet lamination, we have seen the different stacks, we follow the different stacking stacking of the laminated sheet, and then we can heat it, or we can use some kind of heat source in the selective position. So, that is how we can put the lamination, sheet lamination can also form. It is also one kind of additive manufacturing processes. And then VAT polymerization or stereolithography, also we can use the photopolymer, and such that you can use the photopolymer and we can pass the heat source in the selective position, and that selective position becomes harder, and then we can remove the remaining part, and then we can follow the similar strategy for the development of the others next layers or subsequent layers. So, in that way that 3 separate most in general the 7 groups of the additive manufacturing processes has been developed. Now, one by one we can see that in general the additive manufacturing is normally use the layer by layer deposition, and of course, one layer at a time, and it is sometimes called the 3D printing process also, and that is why 3D printing process and additive manufacturing process are synonyms. And 3D printing or additive manufacturing is the process, that is the process, but outcome end result is the rapid prototyping. So, rapid prototyping is the output from this 3D printing or additive manufacturing processes. Now, common methods for producing the layer in the 3D printing process. In the 3D additive manufacturing process, what are the common methods for producing the layers? That first is the stereolithography. We will discuss this thing, which is called SLA or SL, or we can sometimes it is called also vat polymerization. Then FDM, fused deposition modeling. So, in these cases the mostly wire has been fused and deposited, and of course, SLM, selective laser melting, the selective position we can run the laser source, and of course, instead of melting it is also possible to selective laser sintering, but selective laser sintering normally follow in case of the non-metallic material, and of course, then it is more focused, that is the recent development of additive manufacturing process or latest development is the direct metal deposition. So, we will try to look into all this methodology, their principle and what way they are different, and in terms of principle that we will try to discuss in this module. Now, apart from this development of additive manufacturing processes by using the conventional development what we have discussed so far, but there is a possibility of development of this additive manufacturing process from using the principle of the oiling process. So, in the oiling process, in some oiling process we can use the material deposition, or directly we can use the heat source of the oiling process, and that if we feed the extra material we can add to the oiling process by feeding the extra material, then this is also possible to convert this simple oiling process to additive manufacturing process, or we can say that mostly the metal printing processes. So, normally oiling process, fusion oiling process, normally we use the some consumable wire or consumable electrode. So, that consumable electrode also this is also in principle the deposition of the material in a particular position, and such that two materials can be joined in case of welding, but similar principle can be used for the development of the additive manufacturing technologies, or we can say the 3D printing metallic, to develop the 3D metallic printer. So, one important part in welding processes is the gas metal arc welding process. This is a very old welding process, and in cases the gas metal arc welding process, there is some the process itself the sustained by use of the consumable electrode, and there is a pull of the wire and there is a continuous pass of the wire for the deposition process. For now, this pull of the electrode, now we can, if we change the path of this electrode depending upon the particular product for a development of particular layer, and if we follow, if we move that heat source along with the material deposition, it is a predefined path, then it is possible to develop the layer by is a particular metallic layer, which is the principle of the additive manufacturing technologies. But of course, GTAW or other autogeneous fusion welding process can also be used, but in these cases we need to develop some kind of the material feeding system such that we can, it is possible to develop that some certain metal printing process. Now, metal addition in a laser welding process, it is also possible metal addition to the laser welding process to develop the metal printer also, but out of that GMAW, gas metal arc welding process, can also be used for the development of the 3-dimensional low cost metallic printer. But before doing that, we need to analyze the gas metal arc welding process, their mode of metal transfer. So, mode of metal transfer in gas metal arc welding process is one aspect such that which mode of the metal transfer may be applicable for the development of the additive manufacturing processes. So, it may be continuous mode or pulse mode, that means this is the application of the source of the heat, both can be used, the pulse mode and the continuous mode of the current supply for the development of the additive manufacturing using the gas metal earth cooling process. But of course, more development has been happened in terms of the metal transfer, that is from CMT, cold metal transfer. CMT is the in cold metal transfer is the new form of the gas metal earth cooling process. It's a, we can say the CMT cold metal transfer is a some modification of the gas metal or advanced level of the gas metal earth cooling process. But of course, it is not exactly cold, but metal transfer normally happens relatively low heat input, that is why it is called the cold metal transfer process. Now, in transfer of the molten metal from the consumable electrode to the oil pool, so that we need to understand this metal transfer process. So, that will helpful to analyze that which mode of metal transfer is actually feasible or suitable for the development of the metal printer. This is the first step for the development of a metal printer using the gas metal earth cooling process. So, of course, other part also important to consider that actually influence the metal transfer mechanism, that is Selling gas composition, gas flow rate and the composition of the electrode and size of the electrode all actually influence the mode of the metal transfer. And apart from the current, voltage and arc gap, that is the main parameters for the gas metal earth cooling process, the what are the current supply to create the arc and what is the voltage has been used for the for particular welding process and what arc gap should be maintained during this welding process. So, apart from that, the metal mode of the metal transfer in gas metal earth cooling process is like that: short circuit metal transfer, globular transfer and the spray type of. This is the basic three type of the metal transfer normally observed in the gas metal earth cooling process. So, of course, short circuit transfer is the most suitable in metal printing process, because in these cases it is more feasible to control the metal transfer in this process with respect to the globular and the spray type of the transfer, because spray type of the transfer is sometime not, it is very difficult to control, to focus in a particular zone, particular area, and of course, the similar difficulty also arises in practically. It is very difficult to achieve the globular transfer, because globular transfer is the normally it is a by the gravity of the molten material. So, it is a time, it is a the metal transfer formation of the globular formation and the transfer of the metal takes a relatively much more time as compared to the other type of the metal transfer. So, it is very difficult to control the metal transfer by using globular or the spray type transfer. Rather, short circuit metal transfer is more suitable in case of the or for the development of the additive manufacturing or metal printer using the gas metal earth cooling process. Now, apart from gas metal earth cooling process, CMT also more precisely used for the development of the additive manufacturing technology. But of course, I already mentioned that CMT is specifically a part of the gas metal earth cooling process. In principle, it actually used in the reduced welding current and retracting the welding wear at a short circuit conditions. So, that is why ensure a drop by drop deposit of the oil material, but it is oil controlled. Normally, the CMT cold metal transfer mechanism has been developed initially for the thin material, but with the strict control of the oil parameters. But nowadays, the welding of the dissimilar material and even higher thickness material with the improved oil bead aesthetic, that means surface appearance actually very good, and in case of the cold metal transfer mechanism as compared to the normal conventional gas metal earth cooling process. So, therefore, that is why cold metal transfer is more suitable for the development of the metal printing process as compared to the gas metal earth cooling process. So, CMT actually it is a very new process, has been developed 2004, but the main difference for CMT, the metal transfer for CMT process from the gas metal earth cooling process is the mechanized control. So, we use the some kind of the mechanical system to create to detach the droplet and the transfer of the droplet to the desired position. So, that is the difference in terms of the metal transfer process as compared to the gas metal earth cooling process. Now, we can look into that. The difference between the CMT and the gas metal earth cooling process is the main difference in terms of the wire feed. What we can wire feeding, because in gas metal arc welding process wires normally continually feed to the desired positions, and that actually creates the arc and melt it at the same time and deposit the material with a particular position. But in case of CMT process, the wire is actually retracted to the desired to instant the current flow, and it once retracted the wire, there is a breaking of the arc. So, once the breaking of the arc, the droplet is detached from the filler and fuses with the base material and still molten with the base material. So, again the wire moves forward to create the another arc, and of course, all this phenomena actually happens several times in a unit time or in a per unit second. Therefore, the CMT provides a very controlled method of material transfer or deposition, and of course, by sophisticated wire feed system, and of course, this happens normally at low thermal input. So, all these favorable conditions is basically attractive for the development of the metal printing technology, and of course, this CMT actually needs high speed digital control technology to control its metal transfer mechanism. So, that is why nowadays there is a development of the metal printer using the cold metal transfer mechanism. But of course, we can look into that either CMT or GMAW based metal printing processes in these cases. Or if you look into overall that, actually the metal deposition in welding process, what we can control it, but it may not be comparable. And in case of additive manufacturing process, where we can use some laser based system, because laser can be focused into a very small area, and that focused laser can melt, it is a very selective part, a very small part with some desired accuracy is possible, but that kind of accuracy may not able to achieve using the simple GMAW or arc based additive manufacturing technologies, because if there is a need for volume of the metal deposition becomes very high, in this case this arc based technology is more suitable. And of course, the arc based technology, the surface roughness is also not good, smoothness also not good as compared to a laser based system. So, that is why some machining is required to get the desired surface finish. And of course, if you want to produce very small or intricate complex part with good surface aesthetic, then we should not prefer the gas arc based additive manufacturing technology. But of course, we want to develop this additive manufacturing technology using this arc based fusion welding processes. Definitely we need to understand the metal transfer mechanism first, and we have to look into the whether it is suitable for the development of the printing technology, or if it is suitable, then what may be the surface accuracy we can achieve using this thing, or what other strategy we need to follow such that we can use as much as possible very good surface finish. So, pulse MIG to supply the control number of small droplets. So, in that cases as compared to the continuous, maybe pulse mode, it is more easy to control the metal transfer also. Therefore, in that sense pulse mode of GMAW is probably it is more preferable as compared to the continuous mode of the metal transfer in a continuous current supply in case of the gas metal arc welding process. So, therefore, movement of the welding torch is also another important parameter. So, that we need to move the welding torch with the desired path. So, definitely we need to predefine this path, and of course, this according to this path information we need to move the torch. So, in that cases we need to use some kind of the CNC 3-dimensional CNC bed we need to, or if we do not use the 3-dimensional CNC bed, so maybe we can create some kind of the setup where we can control the X, Y and Z movement. So, we can use the simple stepper motor with the lead screw, and we run the stepper motor with the desired, so that lead screw some linear movement in particular direction, it is possible to move that. So, apart from that we can using this stepper motor, lead screw and small arrangement we can develop the X, Y, Z table, so that we can control the X, Y and Z movement. Of course, this cost is comparable as compared to the any ready-made available CNC machines, because CNC machines also we can very precisely control the movement. So, therefore, the welding heat source metal transfer mechanism is one important aspect. Another aspect is the how to move this welding torch is a desired path. Of course, This path can be converted the STL file. So, we can use the computer interface, and by using from the computer interface we can control the movement of this according to the path generated, and normally we export the file in STL file, all the path information are there, and accordingly the torch movement can be controlled. So, this way we can use the relatively low cost metal printing processes, metal printing technology as compared to the very high cost laser based system. Now, apart from this arc based or welding, based on the welding technology, the development of the different additive manufacturing process has been going on, but what we actually understand the additive manufacturing of the metallic components using the most precisely or has been developed so far, that is one is that powder bed fusion technology, and other is the wire feed directed energy deposition and powder feed directed energy deposition. So, powder bed fusion, we use the powder bed fusion. In these cases we create the bed of full of the powder, then we melt the selective part by using some kind of the laser. So, that is the principle of the powder bed fusion, but when you use the directed energy deposition, we just directly at a particular substrate position, we just directly transport the metal. So, it can comes from directly projected the powder at the desired position, and at the same time we can fuse or sinter that powder, or we can directly feed the wire and that we melt the wire and then metal deposition happen. So, it is in these cases it is different from the powder bed fusion in the sense that powder bed fusion we have the layer of the complete layer of the one particular layer of the powder exists, but selectively you are melting that part. But in the second cases here not the selectively, and directly at which position there is a need for the powder and this wire we directly project it at this particular position, at the same time we can melt and or fused or sinter at this particular position. So, that is called the directed energy deposition. So, of course, in these cases initial volume of the metal may be very high, second cases more economically or more economical way we can use the material. That is the basic difference between these two processes. Of course, fusion of the successive layers of the metal using the focused heat source, we can use it in these cases, but using the laser or the heat source can be laser, mostly used in the laser or electron beam, because in laser and electron beam very small diameter, even micro scale, that we can focus a particular area, we can fuse it. Basically, it is a well controlled way, we can heat source can be very controlled in case of using the laser or electron beam. So, that is why the additive manufacturing of metallic components mostly developed using the laser source or using the electron beam source. Of course, in these cases that well defined pre-programmed path is actually required, such that we can, when we create some complicated object, so we define that object. So, we create that object, and that when we create the particular layer, so at which path it should be melt, or that selective path the laser will be focused such that in that part only melting or sintering will happen. So, of course, the other parts also layer thickness, that means what should be the maximum thickness of the layer should be melt, but just it depends on so many parameters, what surface roughness we want to achieve and what are the material deposition rate, all. So, that are the all important parameters in the additive or metallic additive manufacturing process of metallic components, but it depends on the other parameters also. So, focused beam diameter, scanning speed, then powder particle size and powder flow rate, all are this parameter. Shielding gas, what are the types of the shielding gas we can use, nitrogen, argon, that is also having some influence, the shielding gas flow rate, and of course, the solidification, that means when a deposition of the next layer, then we need to know whether this layer has been solidified or not. So, that kind of information is required to decide the path of this thing. So, the getting the optimal solution using so many parameters is sometimes really very difficult. So, that is why the domain, feasible domain of these all parameters is actually very narrow to get a desired product, and maybe if we change of the shape of the products happens, if you use a similar kind of the technology, then we need say lots of trial to develop the range of the parameter, and most of the cases the range of the parameters actually we normally obtain, it is a very narrow range. Of course, in metallic components we can see that consist of many complex physical processes. If we look into what are the different processes actually involved in additive manufacturing process of metallic components, it is having the melting, it is associated with the melting, solidification, and of course, if there is a solidification sinkage, we need to account for that, absorption, then vaporization, wetting, sintering, all this process has to be taken care of. We have to look into that, analyze during the development of this additive manufacturing technology. But so far we have seen that application to metallic materials, in these cases these are the different materials normally we apply all these additive manufacturing processes. Stainless steel, mostly the medical grade steel, and the steels which is having actually low carbon percentage. So, presence of the carbon creates a metallurgical issue for the development of the additive manufactured component. So, therefore, it is very difficult to develop for steel having the very high percentage of carbon. So, it is trying to develop these things, but of course, to getting the feasible range of the parameters is a difficult task in this process. So, that is why stainless steel merging steel, that process has been successfully developed, even nickel based alloy, Inconel, aluminum alloy also, and titanium alloy for all this type of in general materials. The additive manufacturing, laser based additive manufacturing process, mostly the selective laser SLM, selective laser melting processes has been developed so far. Now, we look into the different processes in principle. First is the stereolithography. Stereolithography is the, it is called also vat polymerization also, it is called the SLA or SL process. So, it is widely used, recognized as the first 3D printing process. It is a very old 3D printing process. Of course, it is a laser based process, and that works with the photopolymer resins. Actually, when there is a laser is focused on the photopolymer resins, then the resins react with the laser and actually it cure it and form a solid. So, in a particular position, if you say photopolymer resin, is that we very precisely can control the laser up to this path. So, this path will only solidify, it is only cure and form the solid. So, therefore, according to this path, so it generally accepted as being one of the most accurate 3D printing process with excellent surface finish. So, this excellent surface finish comes from the very precise control of the heat source for the laser, and this surface accuracy actually should be a function of most of the cases is what is the focus diameter of this laser. Now, limiting factor is the post processing is required. For example, we get the desired product and then we have to remove the remaining part. So, that is the post processing steps are required, and of course, stability of the materials may be another issue, because over the time or the cure part, the solid part becomes more brittle with respect to time. So, that is the typical characteristic of the photopolymer resins. So, that is one of the issue using this process. Otherwise, this is the very accurate and very we can expect very good surface finish using this process. And then powder based system. Powder based system, in these cases we can use the powder bed fusion or sintering process. Wide range of materials can be used and functional parts can also be produced. So, different parts they produce for the different kind of the material, or we can say the functionally graded materials can also be used. In this case, in the powder bed fusion process or sintering process, laser sintering is used in the polyamide, titanium and the rubber like materials. So, what happens in this process? So, we create is a powder, one bed that is filled of powder, but thickness of the powder is maintained according to the layer thickness. Now, the laser is moved, fuses the powder according to the path, and that according to the path the laser fuses that particular material, and remaining stay as the loose powder. So, therefore, once one layer is formed, then a new layer of the fresh powder is spread over the surface by a roller. So, we roller and another spreader of the surface over these things, and then again we repeat the same process, and then according to the path we just melt this or sinter that particular position. So, then fused and this attached to the previous layer. So, of course, in these cases no supporting structure is required to support the structure. Basically, the unused powder or unsintered or unmelted powder is basically used as a supporting material. So, therefore, not necessary to support all this material. So, this is the principle of the powder bed fusion or sintering process. If we look into the material jetting or binder jetting system also, it is a most professional prototype, multi-material can also be used, different color can be produced using this additive manufacturing technology, and of course common in design firms. But in material jetting process, the print head. So, what were the principle of the inkjet printing and normally use in inkjet printing? In that principle, this additive manufacturing technology actually has been developed. So, print head distributes the droplets of the photosensitive material, and of course, this droplet of the photosensitive materials once emits, and of course, it is in liquid state and it solidifies under the ultraviolet rate. So, once the droplet forms, droplet of the according to this position, and then upon the droplet there is a ultraviolet ray actually flow. So, that ultraviolet light when is focused on the liquid droplet or maybe on the liquid material, photosensitive material, then this part actually solidify or cure. But in these cases, to extend keep that liquid material, then some support structure is required to support this liquid material. So, most of the example is the thermoset poly photopolymers, acrylics in the liquid form is used for the development in material jetting system. Similarly, binder jetting means instead of using the base material as a liquid, in these cases selectively deposited on a powder bed, bonding these areas to form a solid part. So, simply their metallic powder or non-metallic powder exists. So, here we just it is possible to using some kind of the binding element on that particular path. So, and that path and that position we selectively put the binder element and it binds the powder particles in that form. So, this is the principle of the binder jetting process. So, common metals, sand, ceramics in the granular form can be used as a base material, and along with that we just supply the appropriate binding elements and then it forms the binder jetting process. So, therefore, no support structure in these cases, there is not required to support structure. It is a just like in the powder bed system. So, therefore, no need of the any kind of the support structure in this particular process. Now, directed energy deposition, that is the mostly developed, and now it is developing in this area, directed energy deposition. So, in these cases directed energy deposition is more suitable to make a large parts with the additive manufacturing process. So, the powder based system is limited actually due to the inherent cost and the building time. So, powder based system, so total cost of the powder becomes very, it involves lots of powder during this process if you want to create the very small product, and of course, it takes the huge time. Building time is also much more because there are so many steps at this. So, once layer is formed, then we need to spread the powders for the next layer, and then after that or with a we need to labelize that particular thickness of a powder material. After that we can focus on the laser beam on this powder and to create the shape of the object by following this particular path. So, that is why it is normally time consuming and involves initially due to the involves large amount of the raw materials in this case. So, therefore, it is the development of comes that instead of using this powder bed, maybe it can be use the coaxial feed of the powder at the same time, or wire often to and laser or electron beam. So, particular when laser beam electron is focusing, there we can coaxially focus the either powder or the wire, and such that it form a melted or sintered layer of the on a substrate. So, therefore, powder deposition is synchronized with the heat source. So, that is also required, because with what we can particular position powder is deposited, but accordingly you have to put the apply the laser or electron beam source at that particular position. Of course, we do not use in the powder based system in this process, and scaling of the DED direct energy deposition is possible more easy and most cost effective way and when you try to produce a very huge large big product, basically in this case is more suitable in the direct energy deposition process. But of course, DED can also be used in some kind of the coating technologies that we have discussed in the first part of this module, that different coating technologies. So, therefore, DED can also be used for the to coat the existing structure. In coating application of this, repair of the cracks or defects, in providing the wear resistance coating to a particular position area, or in protecting the site specific area of an object from the corrosion. So, in that purpose also we can use the direct energy deposition. Of course, in the this is more or less this when you try to produce the process, it is equivalent to the laser cladding system also. Now, in general, the 3D printing process having 3D geometry of an object is created, and of course, this is normally done from the computer aided design files, and once we create the CAD model of a particular geometry if we want to produce from the using the additive manufacturing technology, then next step is the slicing this CAD model, and the slicing technology decides the what may be the thickness of a particular material. Of course, this thickness depends on the which additive manufacturing technology you are supposed to use there. Then once this is converted to the CAD file, so converted to the CAD file is required, converted to the usually format .stl file format, and the all data fed to the so the .stl file format. So, all data CAD data actually is basically dumped to the printer process. So, that according to this CAD then the path of the according to the CAD information, the path can be generated, and then part to be melted or solidified metal, and of course, the path is normally controlled by XYZ movement of a table of a movement of the laser source, or it is a 3-dimensional 2-dimensional movement can be used from the table source, and 1-dimensional movement can be used the heat source, that is also possible. So, that most of the 3D metal printing technologies has been developed using the selective laser melting process. And of course, selective laser melting process, it is a basically powder based system. So, here the transformation of the powder metal into a solid metallic object, that is the basic objective of a additive manufacturing process. Now, we will try to look into the different processes, different 3D metal printing processes. First is the selective laser sintering. So, basic elements of the selective laser sintering is the use as the powder source to sinter the powder. They follow the sintering mechanism. So, this is mainly used in case of polymer. So, mainly the sintering process is normally used the polymer. Actually, in the sintering process, we just not cross the melting point temperature, just about the melting point temperature of a particular material, and then the binding may be at the molecular attraction happens between these surfaces without melting of this particular material, that is the sintering process happens, and that similar sintering process what we normally follow in powder metallurgy techniques also. So, here bind the materials together in sintering principle to create the solid structure, and of course, mainly used for the rapid prototyping and the for low volume production of the component parts. So, low volume production if is required, we normally follow the selective laser sintering. Of course, the direct similar to the direct metal laser sintering process. So, this selective laser sintering can also be converted to the direct laser sintering process. So, direct metal laser sintering process, the same concept, but different in technically they are different in this process. We have already discussed the direct metal energy deposition or selective laser sintering or melting processes. Now, in case of selective laser melting, so melter instead of sintering process, so melter materials is actually fully melted rather than the sinter, and of course, allow different properties. Of course, when you melt it, the properties can be different as compared to the sintered components, and it is based selective laser melting is normally based on the powder bed system. So, similarly, selective laser sintering also may be based on the powder bed system, but normally selective laser melting can be based on the powder bed system, and of course, okay. So, apart from that fused deposition modeling, there is another metal printing technology. In these cases, instead of powder, the continuous filament of a material is normally used, and this is fed from the large coil, the same material, and molten metal is actually forced out of the nozzle tip, nozzle head, and then it is deposited on a new layer. So, this is the principle of the fuse deposition modeling. So, in these cases both metallic and non-metallic materials can be used using this technology, but instead of metallic powder we can use the wire based, it is actually wire based technology. Direct metal deposition. So, in this cases use a laser to melt the metallic powder, but it is not based on the powder bed, rather when we are focusing the powder particular area. So, at that area laser is actually focused, so that supplying powder same time it can be melted or fused together. So, actually powders are projected through the nozzle and powders are fused by the focused laser beam. Concept is similar to the fuse deposition modeling, but in this case power is used. Now, if you look into the different aspects of the selective laser sintering, direct metal laser sintering or selective laser melting. So, SLS used to refer to the process applied to a variety of the materials, plastics, glass, ceramics. So, sintering process normally use the non-metallic material. So, basically the plastic, glass and ceramics in that process are normally used. DMLS, direct metal laser sintering, refers to the process is normally applied to the metal alloy. Sintering process do not fully melt the powder, but here to the point that the powder can be fused together on a molecular level. So, in that cases, but with sintering the difficulty is that the porosity of the material can be the porosity of the material can be controlled with the sintering process. Now, if you use the selective laser melting process, so using the laser to achieve the full melt, in these cases instead of sintering the full melting is applied. Powder is actually melted into a homogeneous part, and of course, it working with an alloy we can use the selective laser sintering process in case of alloy, or direct metal laser sintering process. But if case of pure metal, pure for example pure titanium, normally use the selective laser melting process. So, selective laser melting is definitely stronger as compared to the sintering process, but there may be another issue for application of the melting when you try to mix two different metallic powder, and we can or maybe we try to handle the alloy system. So, therefore, melting is advantageous in that selective laser melting is advantageous in the sense that it does not it conform to the melting of the material. So, there is no voids in these cases to prevent no voids, which helps to prevent the failure part. But in case of the sintering process, one may be the difficulty in specifically the metallic materials is the formation of the voids. But of course, sintering process is most feasible using the single metallic powder and combined metallic powder, then sintering is the most feasible there. So, in laser based metal 3D printing technologies, DMD, direct metal deposition is the only one not based on the powder bed. So, this is just kind of summary from this different kind of the printing processes. In selective laser melting and direct metal laser sintering, both the cases the unfused metallic powder is used as a support material and can be reused also. But in case of the DMD, supports can be required to start with the developing the layer to maintain the building object. But in DMD almost all powder is actually transferred into the solid. So, because in DMD processes we normally follow the synchronize the application of the powder, and at this projected area we focus the laser as well also. So, therefore, DMD technology also has the ability to comply with the free form structure. So, free form structure it can form in case of the direct metal deposition structure, but cooling time can be considerable for the laser sintering process. So, that is most important in case of sintering process, but porosity of the issue in case of the laser sintering process, that is another issue. But metal sintering requires of course much higher power as compared to the plastic. Similarly, the melting also require much more power as compared to the plastic. But definitely when you try to process the plastic components in additive manufacturing, we normally follow the sintering process as compared to the pure melting of the polymeric material. Now, if we look into the different parameters associated with the direct metal deposition processes, here you can see that we can create the layer by layer deposition to 3-dimensional object. So, laser power, if we see the laser power used as a power P. Now, scan velocity, that means moving of the laser power, because particular path moves of the laser moves with certain velocity, that is called the scanning velocity of the laser. Then hatch distance delta y and the layer thickness. So, in y direction, what may be the width of a, when you try to produce one particular layer, it is limited to the certain amount of the width. In that cases, that width is delta y and the layer thickness is actually delta z. So, therefore, energy density can also be estimated by this E equal to P by this V into delta y into delta z. So, that is a measure of the energy density. Build rate of this additive manufacturing technology, that can also be estimated the velocity delta y and delta z. So, that is why we can create the build z. So, actually the velocity is moving in the particular direction and the delta y and velocity, if this is the delta y, but velocity is moving perpendicular to that, and this is delta y and delta z in the thickness direction. So, that actually increase the build rate is basically volume flow rate, volume build rate during this process. We can take one example of aluminum with one laser source. We can see that typical velocity is normally 1000 millimeter per second, delta y is in that order around 0.2 millimeter, delta z in the order of 0.05 millimeter, and V is the theoretical build rate, can be estimated around 35 centimeter per hour, meter cube per hour. So, therefore, we can see that in additive manufacturing technology, normally it is very slow process. We can get the only 35 centimeter cube material deposition per hour if we consider all these parameters. So, of course, another important aspect parameter in direct metal deposition or in general additive manufacturing technology is the particle size. So, particle shape and size. So, particles normally spherical particles, of course, it is the range of these particles is like that 10 micrometer to the diameter, basically 45 to 63 micrometer is the diameter of a particles in that range. So, of course, if you try to create that size, uniform size of the particles, then cost becomes very high to create that kind of to create the metallic powder also. So, in that sense metallic powder becomes more costly as compared to the raw solid metal. Good flowability is also required for this powder. Dryness, need to maintain the dryness of the powder. It is a product quality depends on that, and of course, maintain the pureness without any additive or this thing. That is also another aspect for producing the for usability of the powder in additive manufacturing technology. So, that is why we try to look into the quality of the powder. So, cost of powder becomes very high. So, that is the one issue in case of the development of the additive manufacturing processes or in the economical situation to produce a particular object using the additive manufacturing technology metallic powder. Thank you very much for your kind attention.